Hello, my name is Bill. In this video I'll talk about how to generate a fractal tree. So I can set the level and the length, the angle, $90. Can go more, but it turns in on itself. So I can add some random jitter to the angles. Can make the branches bendy. Can taper the branches. And multiple branches. Actually I only have 3 branches. And I can set the trunk to brown. So can also combine these random, bendy, tapered. So when I click another one here, multi-branch, so it redoes the random values for the angles and the bendy part when it redraws it. And brown. So if I turn on multi-branch, you can't really go more than 10 levels because my computer's too slow and Python's too slow. But without the multi-branch, I can go a little higher. Beyond 15 levels gets a little slow. So that's basically all the program does. So before looking at the code, I'll do a simplified version of the program. So this one doesn't have all the extra features. So to get a better display of 90 degrees for higher levels, I probably need to start with a longer initial length. So I'll look at the code for this one first so you can see the algorithm without the extras. And I'll talk about the graphical user interface elements in a separate video. This video will just be about drawing the tree. So I initialize the object instance of the class. So I pass it a screen to draw on, set a default for the length scale and a default for the angle. And then what you do is call draw with a start position for the trunk and the length of the trunk and the angle you want and how many levels you want. So the angle gets saved in the object. So then these 5 lines, what they do is take the length scale and scale it, reduce it down so that the space on the screen is pretty well the same for all levels. So if you watch closely when it's drawing it, for higher levels the trunk shrinks. So then you call draw branch. So if it's at level 0, then return and you're all done. So take the initial point, the x and y coordinates, and calculate the other end of the line. So take the length times cosine of the angle for the x coordinate, the length times the sine of the angle, for the other coordinate, and you have a minus here because pygame coordinates are upside down. And you get the height of the screen. Actually, that's probably not correct for that minus sign. Here I thought I understood my code, but now there's something I have to go figure out there. Then you draw a line. So the trunk or the branch. So from xy to the end, and this is where you invert the coordinates for y. So the height minus y. Then you recursively draw the branches. So the new length is the length times the length scale. So then you call for the left branch, or one of the branches, and pass the new starting coordinates for it, the X and Y. And the new length. And the angle, you subtract your angle you want your branch at for one direction and add it for the other branch. So you just keep calling until the level reaches 0. So for each branch, it branches out into 2 more branches for the next level. Now we'll look at the one with all the extras. So this one, what I called screen, here calling surface. So in this version I draw on a separate surface from the main display and then split it to the main display. My length scale is 0.75, and in the other program what I called angle, it's called d theta in this one. I originally had d theta, but an AI changed it on me. And set the max level to 0. Oh, I don't think this is used anymore. So this code for draw branch is a little bit longer here. The draw function is the same, with just a change in the variable name from angle to d theta. So you're dealing with 2 different angles, the angle that the branch is at, and then the angle from there that you want the new branches. So the angle from the current branch to the new one is the d theta. So the trunk starts at pi over 2, which is 90 degrees, so that it goes straight up. So in the draw branch, I have these global variables which I set with the user interface. Then I have a jitter angle. So 20 degrees converted to radians. And the height of the drawing surface. And then if my tapered tree variable is true, I set the thickness based on the level. Otherwise, the thickness is 2. Now, if I have brown branches set, if the level is greater than 3, branch color is brown, and if brown branches is not true, then they're all green. Then for bandy branches, so it gets split into 3 segments. So the center one is moved slightly using a random number, so it can be, the angle could be adjusted by anywhere from -0.2 to +0.2. So you calculate the end of that segment. So calculate the second end of the first segment here using the start of the branch. Then you calculate the end parts of the bendy part. And then the end points for the last segment. And in that case, you have to draw a line 3 times to draw the 3 pieces. But if we don't want bendy branches is false, we just calculate the end of the new branch, X and Y coordinates, then we draw a line for the branch. So then reduce the length of the lines for the next branch. And if multi-branches is true, I create a list of 3 angles. So you can make this more random if you want, by randomly choose a number of branches. And if multiple branches is not true, then I just do the normal thing of doing 2 branches. And so for every angle in the list, branch angles, if random angle is set, I creates some jitter to add to the angle. Otherwise the jitter is 0. Then I draw the branch and reduce the level. So that in the end of the current branch becomes the start of the next branch. when you recursively call draw branch. And you add the angle, so the angle of the branch plus the angle that you want the new branch to be relative to that angle, and add a little jitter to it if the random angle variable is true. So in the minimal version of the program, I just had 2 of these draw branch lines, but here I have a loop to do multiple branches. So this code I have 3 or 2, so this gets called 2 or 3 times. So graphical user interface to control this I will have in a separate video. So that's all for this video.